trigonometric equations is what we were looking at immediately before what you've just done. Okay, so let's just remember we looked at like 3 basic kinds, or maybe 3.5 basic kinds of equations with trig functions in them that we can solve. Okay, so we started with the most basic kind, the most basic. Okay, so remembering that for all of these there's a domain. Just for the sake of illustration, I'm not going to write the domain. I'm just going to assume 0 to 360. Basic things are ones like this. Okay, you've just got one trig function equal to a value, and you're expected to find the solutions. And between 0 and 360, you tend to get 2. There are some other examples where you might get 0 or 1 or more, but that's basically it. So that's what it looks like. We shook it up a little bit by adjusting. Now, I'll just give you a bit of a, I'll give you a fancy word here. Adjusting this term, which is called the argument, right? It's what's being put into the actual trig function. So, adjusting the argument, there were 2 main ways that we looked at. We looked at throwing a coefficient in there, so something like this, which had what effect? What effect would that have? It's going to be twice as frequent as the regular old sin x curve, so you're going to get twice as many solutions. You'd get 4 solutions to this from 0 to 360 rather than 2. That was one way we looked at it. Or instead of changing the frequency, we could change what we call the phase, right? So we could move it over. For instance, I think I gave you this. We could move it over, left or right, some number of degrees, okay, and our solutions would move accordingly. The last kind that we looked at is kind of like this, but it's when you introduce, you square something, right? So for instance, if I said sine squared x equals 1/2, and this changed things in a couple of different ways. Number one, it simply changed the value, right? So sine x is not going to be 1/2. Sine x, in fact, should be 1 on root 2, right, when you take the square root of both sides. But it's not only 1 on root 2, it's also negative 1 on root 2. So you get plus or minus. So we noticed that even though this was like more complicated, it's actually kind of easier, because it means that if you're thinking of this, if you're picturing this, it means you have solutions in all quadrants, right? So you'd have, in this case, 45, 135, 225, 315. You get 4 solutions, okay? Or alternatively, if you think about the graph, you're going to slice in at 1 on root 2 and minus 1 on root 2. So more solutions. Therefore, if this is where we've been, it's a very logical next step when we think about, okay, what does it mean to make these harder, right? Is to take this, right? By the way, let me give you some language for this, okay? If I showed you an equation like this, okay? This is a quadratic, we're familiar with calling it that, okay? But this is, more specifically, it's a quadratic in x, right? Let me even write that down. It's a quadratic in x. X is the variable, right? So if I change this up and I said this, okay, this is still a quadratic, but it's a quadratic in y, okay? So therefore, it doesn't take that much imagination to think, well, I can have quadratics in all kinds of other things. I just take, these bits and I just replace them with something else, okay? So I'm going to give you a series of examples. I've got 6, and this is why I rubbed off the homework. I'm going to write them all here. Some of them are simpler than others. We're going to add more layers of complexity. For all of these, you may, if it helps you, I don't think it's necessary, but if it helps you, you may approach these by using a substitution, okay? So for instance, you might say, for number 1, the traditional variable for substituting for these kinds of things is u, because x and y are taken, and z generally means something quite different, and don't ask me about B&W, u is the traditional one. So I could say let u equal cos theta, okay? Now if that's what I'm defining, then I could rewrite that equation like so. Okay, now, just before we move off this, okay, and come back to the trig functions, just like if you receive this in algebra, right? You could divide both sides by u, but you shouldn't. Why not?
Because you lose the solution.
Okay, right. If I had divided both sides by u, I wouldn't get anything wrong assuming u is not 0. I would get u equals 1, which is a solution, okay? But, as has been pointed out, it's not the only solution. we've transformed the quadratic into a linear equation. So you'd expect, oh, I was having two solutions, but now I've just got one. Okay, so that's why they disappear. Instead, what would be a better way to approach this question? Okay, and my suggestion was, let's take out a factor of u. Okay, so I've done it. From here, you can go ahead and you know what to do in terms of the algebra, right? I'm just going to suggest, particularly for a case as easy as number 1, or even number 2, or well, actually for all of these, you don't necessarily need to go to the lengths of defining the whole thing. You can just work with it as it is and do the same kind of steps. So, for instance, instead of this, I'm just going to start the first line. I'm going to go cos squared equals cos, take it over to one side, and then factorize it as you normally would. And now you can solve it, okay? So there are two ways to solve this, one for this factor and one for this factor, right? So the way I would set this out is I would lay it out like that. I'd say cos theta equals 0 will give me one of the solutions, and cos theta equals 1 will give me the other set of solutions, right? So where does cos theta equal 0? What values? I'm not to 360, right?
90.
90 and 270.
Oh, that one.
90 and 270, that's what I meant to say, okay? And then for cos theta equals 1, again, two solutions in the domain. 0, all the way down, all the way up, and 360.
180.
So that's a comma, by the way. Yes?
If we are not given a range in which theta can lie, doesn't that mean it could go beyond 360?
Yes, and you will be given a domain. I will talk about what happens when you don't get given a domain, which is a later part of this topic. But just because I'm kind of sick of writing it and I want to save space and whiteboard marker ink, I'm just saying 0 to 360 for all of this. And that will be the default, okay? So the next most common is minus 180 to 180 when they just try to throw a curveball at you, but 95% of the time, okay? Okay, now, strictly speaking, I really should tie this all up in a bow and say, look, here's two parts of it, and I should say therefore, and then I should list out all four. Okay? In this case, because they're so close to each other, I could probably get away, you could probably get away with just writing that, but sometimes, like one side will be dramatically easier to solve than the other side, and there'll be like a mess here, and by the time you've gotten to the end of 6 or 7 lines, this answer and this answer are far, far apart. Okay? So it's worth taking the 10 seconds to write them 0, 90, 270, 360, all in a row. Okay? And that's it. That's all there is to it.